Good morning, students. Today we are going to see the problems in exercise 12.2. First problem, if A and B are mutually exclusive events, P of A is equal to 3 by 8 and P of B is equal to 1 by 8. Then find P of A bar, second one P of A union B, third one P of A bar intersection B, fourth one P of A bar union B bar. Okay, so what is given? P of A is equal to 3 by 8 and P of B is equal to 1 by 8. So they asked us to find P of A bar. So the previous class we have studied the formula. So P of A bar can be written as 1 minus P of A. Okay, so here your P of A is 3 by 8. If you substitute and if you take LCM, the answer is 5 by 8. Coming to the next one, you have to find out P of A union B. And here it is given that A and B are mutually exclusive events. Mutually exclusive events means there is no event in common between A and B. So therefore P of A intersection B is equal to 0. You know that in the first class itself, P of A union B is equal to P of A plus P of B if A and B are mutually exclusive events. So if we substitute this formula, P of A as 3 by 8 and P of B as 1 by 8. So the answer is 4 by 8. 4 by 8 can be written as 1 by 2. So the next one, third subdivision, P of A bar intersection B. So the formula is P of B minus P of A intersection B. So yes, previous class we have learnt it. So the P of B is 1 by 8. Here A and B are mutually exclusive means P of A intersection B is equal to 0. So the answer is 1 by 8. Here P of A bar union B bar. So A bar union B bar can be written as A intersection B the whole bar. So therefore the probability of A intersection B the whole bar. In set language, we will use De Morgan's law. A bar union B bar can be written as A intersection B the whole bar. Here the probability is added. So probability of A bar union B bar is equal to probability of A intersection B the whole bar. How it looks like? It is P of A bar. So A intersection B, if you consider as A, it is P of A bar. So P of A bar, how will you write? 1 minus P of A. So in the place of A, what you are having? A intersection B. So P of A intersection B, the whole bar can be written as 1 minus P of A intersection B. And you know that A and B are mutually exclusive events. So P of A intersection B as B is equal to 0. So the answer is 1. Okay, coming to the second problem. If A and B are two events associated with the random experiment for which P of A is equal to 0.35 and P of A or B is equal to 0.85 and P of A and B is equal to 0.15. Here you have to find out for 3 subdivisions. Okay, so here we'll go for the first subdivision. Before that, what is given? P of A is equal to 0.35 and P of A or B. A or B means it is P of A union B. A or B. So you have to use the symbol union. P of A union B is equal to 0.8. A and B means you have to use the symbol intersection. So P of A intersection B is equal to 0.15. What is asked in the first subdivision? P of only B. So no A should be there. So only B can be written as it is P of A bar intersection B. So in the Venn diagram you can see very well. It is P of A bar intersection B. So what is the formula for P of A bar intersection B? It is P of B minus P of A intersection B. So if you want to substitute what is needed, P of B is needed. So it is not given here. So you take the result of P of A union B. If A and B are any two events, okay, if it's so, P of A union B can be written as P of A plus P of B minus P of A intersection B. So what is P of A union B? It is given as 0.85. P of A is 0.35 plus P of B minus, what is P of A intersection B? That is 0.15. Okay, so 0.35 minus 0.15 is 0.20. If you bring it to the left side, it is minus 0.20. So 0.85 minus 0.20 is 0.65. That is your P of B. After finding P of B, you have to substitute in this result. So therefore, the probability of only B can be written as, what's the formula? P of B minus P of A intersection B. P of B is 0.65. P of A intersection B is 0.15. So if you subtract, the answer is 0.50. In the second subdivision, what is asked? P of B bar. So what is the formula to find P of B bar? It is 1 minus P of B. So P of B, just now only we have found, that is 0.65. If we subtract from 1, what is it? 1. So it is 1.00. From that you have to subtract 0.65. So here 10 minus 5 is 5. Here you will have 9. So therefore 9 minus 6 is 3. So here your answer is 0.35. And P of only A alone, no B. So it can be written as P of A intersection B bar. So P of A intersection B bar can be written as P of A minus P of A intersection B. So P of A, it is given, that is 0.35, and P of A intersection B also given, that is 0.15. If you subtract, your answer is 0.20. And coming to the third problem, a die is thrown twice. Let A be the event. First die shows 5. If the first die having 5, that is the A event. And B be the event, that second die shows 5. Second die, if we have the number 5, that is the B event. Find A union B. Okay. So see now, first a die is thrown twice. So you will get the sample space. So that is 1, 1, 1, 2, 2 up to 6, 6. Okay. So therefore n of s is equal to 36. Now it is denoted, let A be the event that first die shows 5. So in the first die, if we have the number 5, that is the A event. So what are the elements in the A event? That is 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. On all the events, the first die having the number 5. So what is n of A? N of A is equal to 1, 2, 3, 4, 5, 6. So 6 elements. How to find P of A? N of A by N of S. N of A is 6 and what is N of S is equal to 36. So therefore it is 6 by 36. Next we have to go for B be the event. What is B? It is a second die shows 5. So second die shows 5 means what are the elements will have? 1, 5, 2, 5, 3, 5 and 4, 5, 5, 5, 6, 5. So I have written. So n of B is equal to 6. So P of B is equal to n of B by n of S, that is 6 by 36. And you see that your A and A event and the B event. So this 5, 5 is common in A and B, isn't it? So therefore you will have the intersection. So directly I am finding P of A intersection B is equal to n of A intersection B divided by n of S. What is n of A intersection B? So only one element is common in both the events. So therefore it is 1 by 36. So what is asked? P of A union B. So P of A union B formula is P of A plus P of B minus P of A intersection B. What is P of A? So we have found your P of A is equal to 6 by 36. So and P of B here you are here. It is here. So it is 6 by 36. And minus P of A intersection B is 1 by 36. So the LCM is 36. If we add the numerator, 6 plus 6 is 12. 12 minus 1, that is 11. So the answer is 11 by 36. And coming to the problem number 4. The probability of an event A occurring is 0.5 and B occurring is 0.3. If A and B are mutually exclusive events, here again they are given A and B are mutually exclusive events, then find the probability of A union B and P of A intersection B bar and P of A bar intersection B. So what is given? The probability of an event A occurring is 0.5. So P of A is equal to 0.5 and P of B is equal to 0.3. And it is given that A and B are mutually exclusive events. So there is no outcomes common in between A and B. So therefore P of A intersection B is equal to 0. And what's the first result is asked? P of A union B. If A and B are mutually exclusive events, P of A union B is equal to P of A plus P of B. So it is 0.5 plus 0.3, that is equal to 0.8. And coming to the second subdivision, P of A intersection B bar. What is the formula? P of A minus P of A intersection B. Here A intersection B, it is a null set. P of A intersection B is 0. So the answer is 0.5. And you see here third subdivision, P of A bar intersection B. What is the formula for that? P of B minus P of A intersection B. P of B is 0.3 minus P of A intersection B is 0. So the answer is 0.3. Okay, coming to the problem number 6. Okay, the probability that a new railway bridge will get an award for its design is 0.48. The probability that it will get an award for the efficient use of material is 0.36. And it will get both awards is 0.2. What is the probability that it will get at least one of the two awards, and the second one it will get only one of the awards? Okay, so first we have to denote the events. So let A be the event of getting an award for its design. Let A be the event that the railway bridge will get an award for its design. Okay, next let B be the event of getting an award for the efficient use of material. Okay, so we will get two awards. One is for its design and another one is for the efficient use of material. So we have denoted the award for its design is A event, and the award for the efficient use of material is B event. So here in the first sentence, the probability that a new railway bridge will get an award for its design, so it is 0.48. So for getting award for its design is A event. So therefore the probability P of A is equal to 0.48. And next one, the probability for the efficient use of material is 0.36. So here P of B is equal to 0.36, and it will get both awards. Both awards means A and B. So A and B is nothing but P of A intersection B is 0.2. So what are the results are given in the problem? P of A is equal to 0.48 and P of B is equal to 0.36. Both the awards, A award as well as B. Okay, both the event happened. So therefore it is P of A intersection B, that is equal to 0.2. Now coming to the question, what is the probability that it will get at least one of the awards? At least one of the awards means it is greater than or equal to 1. So it may be one award or two awards. Okay, so therefore the first award, probability of getting at least one award is nothing but either A or B or both. So therefore we have to find out P of A union B. So for the first subdivision, getting at least one of the two awards is nothing but P of A union B. So what is the formula for P of A union B? P of A plus P of B minus P of A intersection B. So P of A is 0.48 and P of B is 0.36 and P of A intersection B is 0.2. So if you add these two, your answer is 0.84 minus 0.2. So 0.84 minus 0.2. So here you have to write 0. If you subtract 4, 8 minus 2 is 6. So the answer is 0.64. Okay, and coming to the second subdivision, it will get only one of the awards. That means only one award, the railway bridge, it has to be given to the railway bridge. So therefore, P of getting only one award. Only one award means if suppose the award is given for its design means at the same time, what is it? The for the efficient use of material, you should not give the award. So therefore, it is P of A intersection B bar. What is A? Getting an award for its design means you should not get the award for the efficient use of material. Both has to done. So therefore A intersection B bar. Or otherwise or என்றதுனால here we have written plus. So P of what has to come? A bar intersection B. So here A bar means it is not, the award is not given for its design. So only for the award is given for only the efficient use of material. So probability of getting only one award means it is P of A intersection B bar plus P of A bar intersection B. So what is P of A intersection B bar? So the formula is P of A minus P of A intersection B. And P of A bar intersection B, the formula is P of B minus P of A intersection B. So therefore P of A plus P of B. And how many P of A intersection B? 2. So both are in negative. So therefore minus 2 P of A intersection B. So the P of A is 0.48, P of B is 0.36, minus 2 into P of A intersection B is 0.2. So if you add these two, your answer is 0.84 minus 0.4. So 0.84 minus 0.4. Okay, so if you subtract it is 4, 8 minus 4 is 4, so the answer is 0.44. Okay, so getting at least one of the two awards means you have to find out P of A union B. It is getting only one award means it is A only or B only. So therefore P of A intersection B bar plus P of A bar intersection B. Thank you, students.